All right, so the other day I was playing around with the Cloud AI for the first time. This is the competitor to ChatGPT that's from Anthropic. And I was just talking to it, trying to figure out some stuff, asking it some questions about random problems I was having. I guess some point in the conversation with the AI, I remembered that AI have points in history that their data is updated to. In Cloud's case, I believe it has data updated to April 2024, I think, and ChatGPT is many months earlier than that, or even maybe a year or more. But I thought to myself, this seems like a pretty big restriction because wouldn't it be way more productive for AI to have access to the internet directly and then give you information that way on a real-time basis? I didn't know why this was the case, and I engaged Cloud in a conversation about why that is the case. So I asked it a few questions, and I kind of want to go through that conversation that I had with Cloud and share my findings. Now, originally for this video, I had planned to have the prompts be in Joe Rogan's voice. I thought it would be really interesting that way. However, looks like there's some issues now with a lot of those AI voice celebrity companies like 11 Labs. I set up an account. They want you to verify that the voice is your own voice, which kind of doesn't make any sense. Why would you want to replicate your own voice? Maybe there's some use cases for that, but probably the grand majority of people who use 11 Labs use it to replicate celebrity voices. Anyways, in this case, I looked at other options. They were all pretty bad. So unfortunately, no Joe Rogan voiceover for this video. However, I will try and give Cloud its own voice. I'll figure that out while I'm editing this video. I'm literally just gonna go verbatim as to my prompts and Cloud's responses. So here we go. Let's start with prompt 1. That started it all. So I'd asked Cloud, why aren't AI models provided with constantly updated data from the internet? Cloud responded,
This is a fascinating question that touches on several key technical and practical challenges. Real-time internet connectivity for AI models poses significant risks and technical hurdles, data quality and reliability. The internet contains massive amounts of incorrect, biased, or misleading information. Distinguishing reliable from unreliable sources in real time is extremely difficult. Information would need extensive verification and filtering, technical complexity processing, and integrating real-time data. While maintaining model stability is challenging, models would need sophisticated systems to understand context and update their knowledge base coherently. Current training methods rely on carefully curated, cleaned datasets. Security concerns. Direct internet access could make models vulnerable to adversarial attacks. Bad actors could attempt to poison the model's knowledge base. Privacy concerns arise with real-time data collection. Resource requirements. Continuous training and updating requires immense computational resources. Real-time processing of internet data would be extremely expensive. Storage and processing of constantly growing data presents scaling challenges. There are ongoing efforts to develop systems for more dynamic knowledge updating, but for now, periodic retraining with carefully vetted data remains the safer and more reliable approach. What are your thoughts on the trade-offs between having more current information versus ensuring reliability and security?
I thought. The reasoning of ensuring reliability and security makes sense. What is the process in which a team working on an AI model remedies these issues and then updates the AI data?
The process of updating an AI model's knowledge typically involves several carefully managed stages. Data collection and filtering teams collect new data from various sources: academic papers, news, books, websites. Automated systems filter out low-quality content, duplicates, and obviously problematic material. Content is screened for harmful, biased, or inappropriate material. Data cleaning and preparation data is normalized into consistent formats. Metadata is added for categorization and tracking. Quality assurance teams verify samples of the collected data. Special attention is paid to ensuring factual accuracy and removing potential training artifacts. Testing and validation. The new dataset is first used to train a test model. Teams evaluate the model's performance across various benchmarks. They specifically check for regression in existing capabilities, accuracy of new knowledge, potential biases or unwanted behaviors, security vulnerabilities, integration, and deployment. Once validated, the new data is used to update the production model. This might involve full retraining from scratch, fine-tuning on just the new data, architectural updates if needed. Extensive testing is done before public release. Monitoring and iteration teams monitor the updated model's performance. They collect user feedback and track issues. This information feeds into the next update cycle. This is a significantly simplified overview. The actual process involves many more technical details and safeguards. Would you like me to elaborate on any particular aspect?
I guess my point being is, considering this process takes a significant amount of human feedback, within which time data is constantly being added to the internet, for now it does not seem possible for the data update to keep up with information being placed on the internet. Is that an accurate statement?
Yes, that's exactly right. There's an inherent lag time built into the process. By the time new information is collected, verified, cleaned, tested, and integrated into an AI model, even more new information has been added to the internet. It's like trying to take a complete snapshot of a rapidly moving target. To put it in perspective, hundreds of millions of new web pages are created daily. News events unfold in real-time, scientific papers are published constantly. Social media posts are generated by millions every second. Meanwhile, the responsible AI update process requires careful verification of sources, testing for accuracy and safety assessment of potential biases or harmful content, technical integration, and validation, all of which can take weeks or months. This creates an unavoidable gap between current events, charged information, and what AI models know. It's similar to how textbooks or encyclopedias can never be completely current. By the time they're edited, printed, and distributed, some information is already outdated. This is one reason why it's important for users to understand that AI models should not be relied upon for the very latest information, especially about current events or rapidly developing fields.
Is there a plan in place to have data updated to AI frameworks in real time?
From what I know as of my last update in April 2024, there are significant challenges and differing philosophical approaches to real-time AI updates among major AI companies and researchers. Current approaches being explored: building AI systems that can directly search the internet for information, like Microsoft's; integration of Bing with GPT-4; creating hybrid systems that combine static knowledge with real-time search capabilities; developing more efficient methods for continuous learning that don't require full retraining. Major challenges to solve: developing reliable fact-checking mechanisms that work in real time; creating systems that can integrate new information without catastrophic forgetting; building safeguards against real-time manipulation or misinformation; managing the computational resources needed for continuous updates. Different company approaches. Some companies are focusing on search integration. Others are working on faster update cycles for their base models. Some are exploring ways to supplement base models with current information. However, since this touches on ongoing developments in the field and company strategies that may have evolved since my last update, I'd encourage you to check the latest announcements from major AI companies for their current approaches. What I can say is that real-time updates remain a significant technical challenge that hasn't been fully solved yet. The industry seems to be moving toward hybrid approaches rather than pure real-time updates.
What is meant by catastrophic forgetting?
Catastrophic forgetting, also known as catastrophic interference, is a fundamental problem in machine learning where neural networks tend to abruptly forget previously learned information when learning new tasks or information. Here's a breakdown. How it works. Neural networks learn by adjusting connection weights between neurons. When learning new information, these weights get modified. These modifications can overwrite or disrupt previously learned patterns. This can cause the model to rapidly lose its ability to perform earlier tasks. Real-world example. Imagine an AI model that's trained to recognize cats and dogs. You then train it on birds and fish. The model might become good at identifying birds and fish, but in the process, it could lose its ability to recognize cats and dogs. Why it's catastrophic? The forgetting isn't gradual. It can be sudden and severe. Earlier learning can be completely overwritten. This is unlike human learning, where we generally retain old knowledge while learning new things. The effect can be especially problematic when trying to update models with new information. Current solutions being explored: elastic weight consolidation, EWC. Protects important weights for old tasks. Rehearsal methods. Periodically reviewing old information. Separate networks. Using different neural pathways for different types of knowledge. Modular architecture. Compartmentalizing different types of learning. This is one of the key challenges in developing AI systems that can learn continuously, like humans do, rather than requiring periodic, complete retraining.
So for instance, in the real-world example, the reason the model gets confused is not because it is being shown birds and fish, but rather because it was taught to recognize cats and dogs, and thus assumes that the input will be cats and dogs, when it is in fact birds and fish.
Not exactly. The issue isn't about assumptions or expectations. It's more about how neural networks store and modify information at a fundamental level. Think of it more like this. Initial training, cats and dogs. The network creates specific patterns of neural connections to identify features like pointy ears, charsh, likely cat, wagging tail, charsh, likely dog whiskers, charsh, likely cat panting tongue, charsh, likely dog new training, birds and fish. To learn to identify birds and fish, the network must modify these same neural connections. So now it might change to feathers equals bird, fins equals fish, wings equals bird, gills equals fish. The problem, the network isn't creating new, separate connections for the new knowledge. It's overriding the old connections because it's using the same storage space. The weights and connections that were optimized for cats and dogs get modified for birds and fish. It's not about assumptions. The original knowledge is literally being erased or corrupted. It's more like writing new text over existing text on the same paper, rather than writing on a new page. The old information isn't being ignored or misinterpreted. It's being overwritten. This is very different from human learning, where we can generally add new knowledge without destroying old knowledge, because our brains have mechanisms for creating new neural pathways without necessarily disrupting existing ones.
I see. So there is a storage limitation to the amount an AI model can learn. Thus, catastrophic forgetting is a literal forgetting, as in the data on dogs and cats is lost or overwritten because new, unrelated data is being fed into it. Does that sound about right?
Yes, that's exactly right. The term catastrophic is quite literal. It's not just that the model becomes confused or prioritizes new information, but rather that the old information is actually overwritten and lost. To extend your understanding with an analogy, imagine you have a whiteboard with limited space. First, you write detailed instructions about cats and dogs. When you need to write instructions about birds and fish, you have to erase some or all of the cat-dog information to make space. The new information literally replaces the old. It's not stored separately. Current neural networks often work similarly. They have a finite number of parameters, connection weights. These parameters are what store the learned patterns. When learning new things, they must modify these same parameters. There's no built-in mechanism to automatically expand and create new storage space. This is one reason why AI models require such careful training and retraining processes. You can't just add new knowledge without risking the loss of existing knowledge. You often need to retrain on both old and new information together to maintain performance across all tasks. This limitation is also why researchers are exploring approaches like modular architectures, separate sections for different types of knowledge, dynamic network expansion, adding new neurons, chops, connections as needed, memory mechanisms that better mimic human learning.
Interesting. This leaves me with a fair bit to think about for now. Thank you, Claude. I'll talk to you later.
Thanks for this engaging discussion about AI learning and memory limitations. Your questions helped break down some complex concepts into clearer understanding. Take care and feel free to return with any other questions that come up during your thinking.
So yeah, that was my entire conversation with Claude. Again, this video was meant to be way more entertaining, in my opinion. Having Joe Rogan say my prompts, I thought that would be really funny. I would have also made a mid-journey photo of him. All this stuff I had planned squashed because of some issues with using AI celebrity voices, even if it's for a satire reason. No matter though, I did find this topic interesting, and so I wanted to dig into it anyway and make this video for you guys. So if you enjoyed, like, subscribe, helps out the channel a lot. And yeah, thanks for watching.